Hello and welcome. I am going to talk you through how to make a graph in Scratch. And first, I'm going to start by showing you this cute little game I made. We're going to recreate this game. If you want to stay for that part, if you just want to stay for the cute game, that's fine too. And I'll begin my tutorial with how to do the graphing part. So if you want to stay and make the whole thing, that's fine. If you're just interested in how to replicate a graph in Scratch, I'm really pleased with how this one has turned out. So this link is in the description underneath if you want to head over there. At a minimum, copying some art from it is going to save you some time, and I'll show you how to do that. But let's go full screen on this and see what we can see. So I've got the cat. It says click on me when you start. You'll notice over here that the timer is going and we already have movement on the graph. So this is just graphing the quantity of cats over time. I don't have any numbers on my axes, so please rectify that in a remix for me. But whenever you click the cat, it makes a copy of itself. And so if you click at a steady rate, you'll be able to see a nice straight line forming on your graph. If you stop clicking for a while and let it be a horizontal line, you'll see no growth or no slope there. And then if you want to click faster, your slope of your line will increase. So there are plenty of applications for just graphing a variety of linear slopes there over time. But I also threw in an exponential mode. So if you click the slider down here, it switches you over to exponential mode and you can model exponential growth of cats. So if you click one time, I kind of recommend clicking once about every 5 seconds. Even longer would probably give you a better line. Any less than that and it gets really compressed and it just looks kind of like a vertical line. But if you try to space it out a little bit, you'll get a slightly better exponential curve on your graph there. Scratch does max out at 300 clones, and so you won't be able to get like a fantastic amount in there, but it's enough where you can see the exponential growth curve on there. By the time you get up to this many, you kind of need it to take 5 seconds just to get all the clones in there. And then you see the next one will take us off the top of our graph and we're kind of broken up there. Switching back and forth between modes clears it out, and that's the deal there. In the comments on here, there's a link to a, actually I might not have put it in here. Yes, Scratch doesn't like links in the descriptions, so I just put in this modeling population growth having kittens from the mathematics assessment project. If you Google that, it's this great lesson that you can do that calls attention to the problem of exponential growth among feral cat populations and why we should always spay and neuter our pets, and builds in some really great math in there. So that's a good extension of this if you want to like math up the coding aspect of it. So that's how to play the game. That's how the graph looks and functions, and I'll talk you through the coding. The first thing that I would recommend doing, unless you really want to play around with this yourself and hand make it, which is totally fine if you do, but if it were me, I would want to repurpose as much of this as I could. So I'm going to click See Inside, and then I'm going to click on Backdrops. Once I'm in Backdrops, I'm going to go over here to where it says the little paintbrush icon with Backdrops. And from here, I can grab this. Oh, I hope I can grab this. I think I can drop it into my backpack. Yeah. So in the bottom of Scratch, you have this thing called a backpack. And it's a script code, but I really hope it's not the code. I hope it's the graphic. If not, we'll figure it out. So your backpack is something that allows you to grab things from your programs, from other people's programs. You stick them in your backpack, and then you can put them into your own program. So I'm going to go to File and say New. If you're just on the scratch.mit.edu website, if you click Create, it's the same kind of thing. And then for backdrops, I'm really hoping that this shows up, but I don't think it's going to, which is irritating, but not the end of the world. I managed to get it to work earlier, so I'm not sure why it wasn't this time. I'll play around with it a little bit, but hopefully you should be able to copy the backdrop and then just put it in there. This isn't essential. It's just to save you a little bit of time playing around with the different things we're going to do. Okay, we're going to leave the cat in because I'll use the cat later, but we're going to start by making a new sprite. So I'm back in my code section. I'm going to choose a sprite. Isn't that what I want? I want the paint a sprite option, and this will let me create one. What I'm going to paint is just a single dot, and that is going to be my what causes the graph to be drawn. So once I make my dot, I'm going to zoom in because it's so small, and I'm just going to line it up with those crosshairs at the center. That just makes it a little bit more intuitive when it comes time to tell it where to be on the screen. If it's lined up on those crosshairs, it's not really necessary. So this time I'm going to do purple. I think I did red before, and I'm going to start by positioning it at the origin of the graph. Once I have it positioned, I tend to accidentally move things around in my Scratch programs and not really be happy at the result. So one of the first blocks I always put in is when the green flag is clicked, and then I'll go up to motion. And if you look at this go to X, and there are these numbers filled in, these are already the numbers of the current position of my sprite. So this means that if I accidentally grab this and bring it over here, now I can just click the green flag and it'll go back to the position I want it in once I have it where I want it to be. Yours does not have to be at 128 and 80. It's entirely up to you. Just once you get it where you want it, make sure you can get it back to that point if you're bumping it around as easily as I am. Okay, so the way that the graph works is we use the pen, and I've already got mine in here somehow, but if you don't, let me show you that again. This little blue icon at the bottom here are the Scratch extensions. There are a ton of them that interact with some robotics programs and things, but the one that we're going to use today is pen. And so when you click on pen, it gives you in all these other options. And the first thing we're going to do is we're going to tell our pen what we want it to look like when it draws a line behind that dot of a sprite. And so I'm just going to call that sprite dot instead of sprite 2. So having it be here is good. Set pen color. I want it to be kind of invisible, so I want it to match the color of my sprite. I'm going to click on this color option, and I've got these sliders around. I could try to replicate that purple that I have it at, or I can use this eyedropper tool down here. It lets me pick anything that's in here, and it lights up that ring around the outside with the color. Now you'll notice if I go on the edges of my purple dot, some of those colors are a different shade. So you want to try to pick something in the center if you really want that like illusion of it being exactly the same color. Okay, so I set pen color. I'm going to start by erasing all. I don't think that one's entirely necessary, but just in case, I'm going to do that. And then I'm going to say set pen size to 4, because that is what I worked out to be about the same size as my dot previously. You can play around with that. You don't have to have it match. That's just what my preference is. Make it be how you want it to be. Okay, I've got it all set up, and now I'm going to say pen down. That means that your pen will start drawing. So once it goes to that spot, changes its color, erases anything else it's made, and changes its size, that's when the drawing is going to start happening. You wouldn't want the drawing to start before this go to command, because if that's the case, it'll put the pen down and then it'll go there and you'll get this straight line across the screen, which is probably not what you want. If it is, more power to you. Now, my next thing I'm going to do is I'm going to tell it how to move. And in order to tell it how to move, I'm going to have 2 variables, sort of. I'll tell you more about that in a second. Just to keep things nice and organized, I'm going to pull in a new when this green flag is clicked for my variables, because I want them to set up in a certain way when I get started, and I don't want to be confused about what's going on here. So when the green flag is clicked, I'm going to go down to variables and click this make a variable button. It's kind of like a gray button. It's easy to look past it, but it's right at the top of the variables menu. My first one is going to be count. Can't spell today. And my second variable is going to be timer. You have the option in Scratch of making these variables visible or not. I kind of want them to be visible. It's up to you if you do or do not, but they are helpful in programming it to make sure it's doing what you think it's doing. And they are also helpful so that your users can see how these numbers relate to what you are graphing over here. Okay, so when we begin, I want the timer to be 0, and I want the count to be 1. And that's really important, and I'll tell you about why later, because it took me a lot of time, a couple times, to realize what my problem was. But that's for a later time. So it is really important that you pay attention to the difference between set to and change by. Set timer to is very different than change timer by. If you're getting weird problems with your variables and things aren't working right, this is the first line that you should be checking for debugging to see if you've accidentally grabbed the change instead of the set. Set means, okay, timer equals 0, count equals 1. Change means, okay, count is 1 more than it was a second ago, and then 1 more than it was the last time that bit of code ran. So you want to be really careful about that. Also, if you ever see that save now up here, go ahead and click it. Scratch does save for you automatically, but it's just nice to help it out if it's taking a minute to save. Okay, so now I want my timer to increase on its own. I want it to go up every second that the program goes by. And so I'm going to pull in another when this green flag is clicked and set up my timer increase. I could just tack it on under here, but I like to separate out my code into like paragraphs that each kind of have a different point. And so I'm going to say that this is going to be in a forever loop. And I'm going to put in this wait 1 second block inside of here. After that, I'm going to go down to variables, and this time I do want to change timer by 1. So what this should do when the green flag is clicked, timer will set to 0, it'll wait 1 second, and then it'll go to 1, it'll wait another second, go to 2, wait 3, for the whole time the program is running. Let's click the green flag and see if that happens. It's looking good. It's going up every second. So that's how the timer is going to work. I actually don't need the timer to do that for the way that I'm drawing the pen, but it's nice to see it there. It just makes it feel better, personally, in my opinion. So let's get to coding this graph so that we're actually doing something. I basically want the dot to change in the X direction, just sort of continuously as time increases. And then I'm going to set it up so that when you click the cat, it makes copies of itself, and that'll change the Y direction. So I haven't programmed the cat yet because I want to give you a feel for the graph, but it doesn't matter what order you do things in as long as everything sort of connects together and makes sense. It's kind of nice. So let's get these programs set in here. I am going to just keep going on this paragraph over here. I'm going to continue describing what to do. I'm going to go back to control and pull in this forever loop again. I'm going to put in a wait block, and I'm going to have it wait 0.1 seconds. I don't want this. I feel like the program will get slowed down a lot if it is constantly checking. And really having it graph more than every 10th of a second, you can't tell very well. So that's my personal choice that I put it in there as wait 0.1 seconds. If you want to have a different amount of wait time in there, go for it. But I think that that's kind of a good spot for me. So that's where I'm going to have it. Now, motion, I'm going to have this change X by, and again, change X by and set X2 are right next to each other. So change X by is the one that you want, not set X2. And every 0.1 seconds, I want it to change X by 0.1. I'm not actually using the timer to tell it how to move. I'm just having it change I've set up its own little timer in here for that dot to move. Okay, and remember, anytime the dot is moving, because the pen is down, the pen will be drawing. So now for my y, I'm going to need to use an expression. I want the same thing here where it says change y by, not, oh no, just kidding, I lied to you. You want set y2. Okay, for this one, you do want set y2, not change y by. So we're changing x, but we're setting y. And inside this set y, we're going to nest some operators. Your operators are your math. We're going to start with this plus one, and we're going to also need a multiply one. And here's what we're going to do. We're going to set the multiplication one inside one of the bubbles on the plus. And you'll notice whenever you get something near in Scratch, something it can drop into, it gets this sort of white halo around it if you drop that inside. So now we basically have it set up so that these two quantities here are going to get multiplied together and then added to this first quantity here. We start out with y being 80, so this is the first number. I'm going to have it be 80 there as well. And this is going to go in this set y2. You can see I can put the whole thing in there. So what we're going to do is we're going to take set y to 80, and then we're going to take the count, whatever the count is, and remember that's going to be in the future when we start making copies of the cat, we're going to have count increase as well, and we're going to change count by 0.3. So now if I run the program, you'll see what happens is the graph starts to slowly move over in the x direction. We're getting further towards the positive end in time, and that's exactly what we're expecting it to do. Count isn't changing because we haven't programmed anything to cause count to change yet, but when we do, that's where it will go up. You don't have to have one of your axes be time. You certainly don't have to have your y-axis be quantity. It could be anything you want. You can actually set it up so that these variables down here, if you click on this, right click, you can have it be a slider, and you can move these around anywhere you would like on the screen as well. So you could have your users put in different values for these, and you could just graph what those are, which is kind of neat. Because count maxes, or because the slider maxes out at 100, instead of having this 0.3 times count, I might have it just be count. And so then, oh no, that's maybe a little high. The point is that you have to calibrate your graph however it makes the most sense to you. So maybe instead of 0.3, I would do 0.5 times count. So that means every time count goes up by 1, your x value changes by 0.5. So that's better. Maxes out pretty soon. Let's try 0.4. I'm in the weeds right now, but it's kind of fun. Oh, why would I pick a... Okay, I was going in the wrong direction. Let's try 0.6. No. 0.7. That's better. I think 0.7 is the sweet spot if you want it to be a slider. So again, you could have something happen in your game and you want your users to watch for that thing to happen, and maybe they're keeping count and every time they have it go up a little bit. I think you can change the slider range. So it defaults from 0 to 100, but you could also have negative numbers in here for your slider. And so instead of going just up, it could go in the negative direction. So there's a ton of things that you could do just by changing that slider around. For my program though, or the standard one that I said I would show you with the cat, we're gonna not have this be a slider, have it be a normal readout. And let's make sure that I haven't messed it up too badly. Yeah, it's doing what we're supposed to. Okay. So we've got that going, we've got time increasing, we've got the graph going over, that's all fantastic. Now we need something for it to count. And so this is where we're going to go back to the cat. And if you're not interested in the cat part of it, you can head out now. It is entirely your choice what you want to do here. But if you want to see how to make the population growth game that I had with the cat, this is what you're going to want to do. Okay. So I think the cat is a little bit large for what I want. So I'm going to start, as always, with some start conditions. And let's make it big so we can see. Okay, so for looks, I'm going to set size to 70% and see how that looks. Yeah, that's the size of cat that I want. Once you have it set, you don't really need this in here. I'm not going to be changing the cat's size throughout the game, so you don't have to have it as your start condition. It could just be in there permanently, but I like leaving it in there. As always, I'm going to move my cat around either accidentally or on purpose, and so I want it to go back. You don't have it go back to this position. That is absolutely not necessary that these numbers for my cat match your cat, but that's just how I'm going to go. And then to help my user out, to let them know what's happening, I'm going to have the cat say, "Click me," when the game starts. So now when you start, the cat's there, it's at 70%, and it says, "Click me" for 2 seconds. Now what I want to do is program what happens when the cat is clicked. So I'm going to go to events and say when this sprite is clicked. And what I'm going to have happen when that sprite is clicked is it's going to make a clone of itself. So I'm going to go down here into the control menu, which is where the clone stuff is, and say create a clone of myself. So now every time I click it, it should be making a clone, and yet I see no clones. I don't know if you can see it in the video, but there's a little yellow halo that shows up around that bit of code in the center of the screen every time I'm clicking. And so it looks like it should be working, and yet I see no clones. Guess what? I didn't tell the clone to go anywhere different than the cat was, so every time I was clicking, there sure was another clone in there. It just was piled on top of the cat, and you couldn't tell. When you hit stop, it gets rid of all clones. So we're going to start over, and we're going to tell the clone, okay, when I start as a clone, which is also in the control menu here, I want it to go someplace different. That's the first thing. So I'm going to choose this glide to random position. Now, let's see what happens. Yay, there we go. Every time I'm clicking, the cat's going someplace else. Now you'll notice one of my cat clones ended up exactly on top of my graph, and that is not what I want. I want to be able to see my graph. So I need something to tell the cat clones not to cover up the graph. This one's a little bit fiddly, but it works really well, and so I'm gonna show you what to do. It's the best solution I've found so far, but it's certainly not the only solution, and it is not a perfect solution. So if you can think of something better, let me know. I'm going to pull in this repeat until block from the control menu. And inside the repeat until block, I'm going to nest a bunch of conditions. I want it to not be over the graph. So the first thing I'm going to pull in is not. And to tell it to not be over the graph, I'm going to tell it, okay, be at x's that are less than this amount and y's that are less than this amount. So I'm going to use an and, which means that, okay, so if I was just putting in, don't be at x's that are less than this, or then I would never have any cats like in this part of the screen over here. There would never be any cats over here if I'm just saying, don't do that. I'm saying it has to be both. It has to be both an x that's above here, that's not what we want, and a y that's above here is not what we want. So it's just going to block out this corner of the screen up here. Because my little graph is really close to the border, I don't have to worry about anything. Like, I still don't want a cat in that little edge right there. So that's going to be okay for me. So inside of this and, I'm going to pull in these bubble. I don't want bubble less than. I want bubble greater than for these two. So we're going to have it be not, you know, I'm doing this on the fly, and I probably shouldn't because it's probably not going to work right the first time, but this is life. So not greater than, why wouldn't I just use less thans? Let's give it a try. Come with me on this journey. We'll see if it works. So I don't know if that's the same thing. Let's see what the cats do. And if it doesn't work, I apologize for wasting your time, but maybe you'll learn a little bit from my mistakes. So inside here, I'm going to want to put X and Y, and I can get that from the motion menu all the way at the bottom. And this is looking at the X position and the Y position of the clone because I'm putting in something that has to do with the clone. So less than, before I said X position should be greater than 74, and that's what I wanted to exclude. So if I do less than 74, and then for Y position 8, let's just see what happens. I pop that whole thing into repeat until, and then what I wanted to repeat until is to glide to a random position. This is looking good already. There were a couple of the clones that did what I wanted them to. Okay, so what I'm going to do here is I'm going to keep clicking, and at some point the cats are going to go over the graph. And when they do, you'll notice they start flying back out, which is nice. However, you'll notice that they are clustering in a specific area, and that's not what I want. So now we've got enough cats that we've kind of defined the box that cats are allowed to be in, and it's excluding a large portion of the screen. So I think I do need not in this corner. I might be able to do it with an or, but at this point, I think I'm just down a rabbit hole and I need to chill out. So instead of X position 74, we're going to do 74 X position, and same thing for Y. All of this goes inside the knot goes inside repeat until. So now, instead of saying be in this corner, we're saying don't be in this corner. So they're going to be everywhere except there. This is what I'm talking about. I didn't think it through like math union wise, whether that was really going to work out. Let's see if this one works out. Not a guarantee, never a guarantee, but it's looking better. The cats are more naturally just avoiding the graph at this point, which is good. Okay. So you'll notice that even though I'm making cats, my count is not changing. And that's definitely something I want to have happen. So I'm going to go down to variables and say change count by 1. So when I start as a clone, increase the count by 1. Again, make sure not to grab set count to 1. It should be change count by 1. So let's take a look at that now. Oh, our graph is going up, which is good. You can see the count is going up and the cats are doing what we want them to do, which is pretty fantastic. All right. So something you may want to do is have a reset button of some kind. And I'm just going to show you how to do that really fast before I get into the exponential mode that we're dealing with. So I'm going to paint a sprite and just do a circle. And I think I want a gradient fill because why wouldn't I? And I'm just going to center it up there. And so now we've got this big button. Actually, there's one other thing I want to add to these cat clones that I forgot about. I want them to, when they are done moving around, to go to the back layer. And the reason for that is if I have a reset button like this, if I don't have this on here, it's entirely possible that a cat clone is going to cover up that button. It didn't, but I think it's possible. So I'm going to leave that go to back layer on there. So in order to reset, what we're going to want to have happen is we want all the cats to go away and we want the graph to go back to the origin. So on here, the only thing I'm going to do is I'm going to say when this sprite is clicked, and I'm going to have it broadcast a message. And that message I'm going to rename to reset. You don't have to. You can leave it as message 1, but I like giving my messages names in case I've got multiple ones in a program so that it makes sense to me and I know what I'm doing. Okay, so now when you click it, it broadcasts reset, but none of the other sprites care about that because you haven't told them to care about the message reset. So first I'm going to go to dot, and I'm going to just scroll over to where I have some open space and pull in when I receive reset. So what do I want that code to do when I receive reset? The first thing is I want it to pick up the pen. I want the pen to stop drawing. So I'm going to put pen up from my pen menu down here. And then I want it to erase everything. I don't want there to be any of the drawing, the graph that had already happened. So now when I click this button, the pen goes up and I erase. You'll notice it's still moving because of the timing, the way that I have it going over every 0.1 second. So we probably want it to go back to the beginning. So motion, I'm going to pull in go to. And right now it's where the current position of the dot is. I want it to match where its original starting position was. So if you have it the same as mine, that would be 128 and 80. If you picked something else, put in whatever else you picked. Okay, it doesn't matter. But now when you hit reset, it'll go back to the start. Oh, I know why. It popped up because of this count thing that threw me. Don't worry about it. We won't worry about that. And then you'll notice it's not drawing anymore. Once I reset, I want it to start drawing. So I'm going to go back to pen and say, okay, once you go back to the beginning, then put your pen down. And you see there, it's immediately graphed this line showing that it's including this count. I probably want the count to be reset as well. So in here, and I am going to just put it all under this reset command. I'm going to go to variables and say set count to 1. And it's important to make it 1 if we're going to do the exponential thing later, and I'll get more into that. And then set timer to 0. So now this is actually behaving. Oh no, I clicked the start button. Just kidding. Let's get some cats in here and see what happens. Okay, so we've got a bunch of cats. We've got a graph. I click reset. The graph resets. And we're all good there. I still have a bunch of cats though, because I still haven't told the cats what to do. So for events, when I receive reset, I'm going to go down to the control menu and pull in delete this clone. Let's try it. Yay. So now we've got a basic program where we can graph the number of cats and we can reset the number. The cats aren't going to just bother the graph. And that's fantastic. Okay, I did forget to say something important. I made a big deal about copying in this backdrop. The backdrop is what has the graph in it. The graph, the axes, and their labels and things need to be on the backdrop because the pen only draws behind sprites. I had originally had the graph as its own sprite, and I couldn't figure out why it wasn't working. The pen was drawing behind it, and I couldn't see it because my sprite had that white background. It wasn't transparent. So when you're doing this, you either need to have your graph be on the backdrop or have it just be lines so that it's got a transparent area so that your graph can go through there. And that took me a minute to troubleshoot and figure out what was going on there. Okay, so those are great. But what if you want to do the exponential mode that I had before? It makes it a little bit more complicated. It's pretty fun. So if you want to see how to do that, let's do exponential cats. All right. The first thing I'm going to do is change this sprite, which should get a name. Let's call it switch, so that it has an exponential and a linear mode. I had that nicely drawn art, like graphic one in the other program I showed at the very beginning. If you want to go in and grab that, that's fine. If not, that's cool too. I'm going to just change this one's color. Let's do green, and I think I like yellow. Yeah, that'll be good. So now I'm just going to change the color of that, and I think I'm going to give it a text label too. I want my text to show up though, so I'll change the color. This is going to be exponential mode. And this one will be linear mode. And we're not going to take any more time with that. Okay, so I'm going to name these costumes though. This one I'm going to call linear, and this one I'm going to call exponential, or just EXP. That's just to help me. There's no reason for that beyond there. So let's start by what I want to have happen here. In the original game, you might have noticed that it like flashes and makes a noise. That's nice, and I'm going to show you how to do that, but it's also totally unnecessary. It's just something that's fun for your user. So the first thing I want to do is bring in an if then else command. And I think I'm actually going to have it go before the broadcast, but that's a little bit hard to do. So I'm going to pull broadcast off the side for now. So it's right now, if you click it, it's not going to reset because I don't have this little block attached. I'm hopefully going to remember to do that at the end. The next thing I want is an operator because I want to check to see what the costume number is. And the way I can do that is I go up to the looks menu, and if I scroll down, there's this one that says costume number. If costume number equals 1, these costume numbers are in order, and you can also see there's a little number up here. So if costume is 1, that means the game is currently in linear mode. I need a variable that's going to help me keep track of which mode I'm in and let the game know. I'm going to call it Exponential. And I'm not going to have it be visible. If you want to have it visible while you're programming, that's a great idea. Just to make sure that it's working the way that you expected. Having those variables on is a really good way to debug your program. But I'm going to be overly confident in my own abilities and turn it off. This variable exponential is going to act like a binary piece of information. It's going to be either true or false. If exponential is 0, that's going to mean no, not exponential, which means we're in linear mode. If exponential is 1, that means yes, exponential, and we're in exponential mode. So if costume number is 1, which is our linear costume, then we're going to set exponential to 1. So if it's in linear mode and we click on it, we're going to change it to exponential mode. And just to get that point hammered home, we're also going to say switching to exponential mode. Okay. So now when I click on this, it's going to tell me it's switching to exponential mode, but it's not going to do anything else because I haven't programmed it yet. The else is if the costume is not the linear costume. So I'm just going to right click or hold control and click if you're on a Mac and copy this in here and say instead switching to linear mode and setting exponential to 0, which means false, not exponential, linear. Switching to exponential mode. Hasn't done anything again. So why am I even trying that? Never mind. Okay. Then one thing that's kind of fun is to have it change its color. And there's this great change color effect. If I go down to control and I say repeat change color effect, let's say by 50 instead of 25, I can click and do this and it blinks really fast. And I don't really want it to blink that fast. So I'm going to put in this wait block and change it to 0.2. Sometimes it goes so fast you can't even see it. And I think I only want it to repeat 4 times. So let's see. That's a much better one. Sounds are fun. Pop is the default sound always. And I'm just going to pull in start sound pop. You can have it make any sound that you like. It is not important at all. Then I'm going to set color effect to 0, just because I want it to go back to its normal color effect. And then I'm going to have it go to the next costume. At that point, I want it to broadcast reset. So let's hopefully start over. Switching to exponential mode, changes color, pops to E. When I click on E, switching to linear mode, changes color, pops to L. Okay, beautiful. So far, so good. I also want to set up my start conditions for this switch, which is always a good thing to do. And I didn't do it first, which I always try to do it first, just because if I don't do it first, sometimes I forget it. So we've got when the green flag is clicked. I want it to start in linear mode. So I'm going to switch costume to linear. This is at the very beginning. I usually always want it to go back to where it began, even though it's not moving, just in case I move it around. And then this is also going to be where I reset the variable exponential to 0, because I want it to always start in linear mode, and exponential equaling 0 means false, not exponential. We're in linear mode. Okay. And that is all the code on there. So now what we need to have happen, our dots code is not going to change. That's still going to do the same thing. It's still going to graph quantity over time. But we need our cat to behave differently in linear mode than it does in exponential mode. In linear mode, every time you click it, it makes one more cat. In exponential mode, it needs to make a copy of every cat. So the first time when there's only one cat, there will be 2 cats once we're done clicking on it. If there are 2 cats, there will be 4. If there are 4 cats, there will be 8. If there are 8, there will be 16. That is exponential growth, okay? I hope I did my math right on that. So right now, it says when the sprite is clicked, create a clone of myself. This is the code that's going to be getting more complicated. So let's dig in. I need to check to see if I'm in linear or exponential mode, because the cat's going to have different behavior in linear or exponential mode. So I'm going to pull this apart for just now, and I'm going to bring in an if-then-else command from the control menu. If-then-else. If, again, I'm going to go to my operators, because this is how I'm going to check for my variable, and I'm going to pull in this equals one, and I'm going to check it against a variable exponential. So if exponential is 0, if exponential is false, not in exponential mode, that means we're in linear mode, it's going to just make a clone of itself. Okay, that's it. That's all. It's the same thing that we had to begin with. We just had to set up this structure of this if-then-else conditional to see, like, okay, if we're in exponential mode, keep doing the same thing we were doing before, but now we have the option to have it do something else. So if it's not in linear mode, if it is in exponential mode, if exponential is true, then what we're going to want to do, and this is really short and sweet, we're going to repeat create a clone of myself, and these are both in the control menu. But the number of times we're going to repeat it is the count. So instead of putting a number in there, I'm putting a variable in this repeat. And so what this is doing is, let's switch it to exponential mode. When I click the cat, when I click the cat, it made a copy of itself. We went up to 2. Now it made 2 copies because our count was 2. Our count is now 4. It makes 4 copies, 8, 16. And this is what exponential growth is. It's saying that, okay, however many there are, make that many copies. So simple to do, but it works out really nicely, and it gives you that great exponential growth curve. The problem I was hinting at before, if you have your initial count way back, I think I have that in the dot code actually. If when you start out, your count is at 0 and it goes to make count number of itself, it just makes 0. So it took me an embarrassingly long amount of time to figure out why my cat wasn't copying itself in exponential mode when it was working just fine in linear. It was because my count was at 0. If you double 0, you just have 0. It was never going to work for me. So you have to start out with count being the number, at least like a non-zero number, if you're going to get any change. You probably don't want a negative either. I'm not exactly sure how Scratch would handle a negative number of loops, but it's probably not what you would want. I do want to try it now to see if that's the case. Okay, I think that is everything that I wanted to show you today. Thank you for spending some time with me. If you do go to the linked program below, oh no, I want to save now because I can see it there. The program that I have in the link below for the official program, not just the one that I made a copy of, if you click see inside, I did comment out all of my code. This is really easy to do in Scratch. If you just right click or on a Mac hold Control and click, you can add a comment to any block in your Scratch. So this is just, we want the cats behind things. So if you go into that link, you can look at every little bit of my code. Some of it might be in a slightly different place than I showed in the video, so I apologize for that. But it does work in the same way. So it's just up to you whether you want to follow the video version or the behind the scenes version that I sort of started with for the idea. And I talked through what each of the pieces do there. Even this graph that was the sprite that is not even visible in here, I talked about how I had that problem with the line that was being drawn by the pen showing up behind it. And so you get a little bit of the background story there. Thank you so much. I hope you enjoyed this, and let me see some of your projects.